Hi guys, I'm Teacher A and I'm here to teach you the GAT, and I have begun with my first lesson with this has been a lesson that hasn't happened for a long time. I did do a few lessons last year, but now I'm going to start regularly and I'm going to be doing this GAT book. So this is the GAT book that I'll be using. It is written by Ibrahim Koshir, and it is also and with his scientific team, Mohammed Rafat, Hamdi Hassanain, and Mustafa Hamza. Thank you, shukran, gentlemen, for giving us such a nice book. It's an amazing book, and I'll be doing the GAT here in my channel. So let's go to page 21, okay? I'm on page 21. So turn to your book on page 21 and we will do the first problem. All right, so let's take a look. What do we call this? The problem goes like this: 3 to the power of 10 plus 3 to the power of 10 plus 3 to the power of 10. Okay? Now, what do we do? Now remember guys, just for a quick refresher, this is called the base, the 3, and 10 is called the power, base power, base power. And we are adding. So what do we do to the exponents? Question. Okay, take a minute to think about it. What do we do actually to the powers? What do we do to the 10, to the 10, and to the 10 when we are adding the exponents that have the same base and the same powers? What do? We multiply them? Not quite. Did somebody say divide? No. We do not multiply and we do not divide. Okay? I'm sorry. We're going to review when we add powers and when we subtract powers, and then we're going to look at how to solve this problem. I'm going to do a little review on exponents before I tell you the answer to this problem and how we get it. Okay? So let's do a review on exponents first. Okay. So there are some rules that we have to follow when we are doing exponents. Rules. The first rule says this, that if you have an exponent with the same base and you're multiplying it, okay, the rule says if you're multiplying, multiplication, that means you have to add the exponents. So, sorry, you have to add the powers, okay? So 4 is the power and 5 is the power in this case. 4 and 5. So the rule says, the rules of exponents says, let's put rules of exponents here. It says that you have to add. You have to add. Okay, so this will give us, you guessed it, 3 to the power of 9. That will be the answer. The next rule is, if we divide an exponent with the same base, the powers could be different, no problem. Okay, when you're dividing, what do you do to the exponents? Anybody remember? That's right, we subtract them. Okay, so we will take the power of 5 and subtract it from the power of 3. So we're taking 5 and 3 and we're subtracting them. Why? Because it's division. That's what the rule says. So this will give us 3 to the power of 2. Okay? So that's the next rule. Oh, by the way, you might find you might see division like this also. Remember, fractions are also division. So this will give you the same thing. 5 minus 3 is 3 to the power of 2. Okay? So that's the next rule. Okay, now, there's also another rule that says if you have a power in parentheses, and by the way, these are parentheses. These are not brackets, okay? Stop calling them brackets, guys, please. These are parentheses. So if you have 3 to the power of 4, and then in the outside of the brackets you have another 5, what will you do to the powers? Very good. If you have parentheses and you have a number, which is the base, and then you have a power, okay, and then you have another power in the outside, notice there's a power here and a power here, and these are the parentheses here, okay? What do you do to that? What do you do to the powers here? Did anybody say multiplication? Bravo, that's what you do. You multiply. Okay, that's the asterisk is multiplication, and this will give you 3 to the power of 20. So now pretty much we covered all the rules, most of the rules. Now there's also another rule that says that if you have something like this, let's say again you have division, because remember, a fraction is division. This is a fraction and it is division. But what do we do here? You say, well, teacher, halas, you told us. You subtract. Good. Exactly, you subtract. But in this case, when you subtract, what do you get? 7 minus 14. Because 7 is a positive and 14 is a negative, you subtract the smallest from the largest and you keep the sign of the largest number. Let me repeat. Which one is the largest? Which one is the largest here? 14 or 7? 14. So you will keep the sign of the negative. So your answer will be negative. Now, ignore the signs now and subtract 14 from 7. That will give you 7. This is 3 to the minus 7. Now, you can't have this. You cannot have 3 to the minus 7. How are you going to, you have to make it positive. 3 to the minus 7, it has to become 1 over 3 to the 7. Now, you're going to say, well, why do we do that? Why do we do that? Because exponents have to remain positive. So you send it down to the bottom of the fraction to make it positive. Okay, so you know the answer to that now. So now let's take a look at this problem here. Okay, is this multiplication? No. So can we add the exponents? No, we can't add them. We cannot add them. So I'm going to put no, we can't use this. We can't use this rule. Sorry, guys. Can we use this rule? This is division. Can we use this one? No, because this is addition. So we can't use this rule either. So sorry, I'm not going to use it because it doesn't apply. We're not dividing exponents here. Can I use this one? Can I use this one? No, because again, we don't have division. And last but not least, can I use this one? Can I use this rule? No, I cannot. Why? Because we don't have parentheses here. So teacher, how are we going to do this if no rule applies? I will show you. So here this is this is addition. Okay, so we have addition, addition. Now, we do not, in this case, when you are adding, you will not touch the powers. Do not do anything with the powers. You see the power of 10, 10, 10? You don't do anything to it. You just leave it like that. Now, here, in front of every single 3, guess what we have? Guess, guess, guess. We have a 1 here. We have a 1. You're going to say, well, how did you get 1? Where did you find this 1 from? Where did I find it? I found it because every single number in front of it, or every single variable, even if you have an x, okay, let's say we have an x here, okay? We have an imaginary, we have an invisible 1 here, an invisible 1, and we also have an invisible 1 here. This is called a coefficient, and this is called a constant. It doesn't matter what we call it really, because we're not here to learn all these weird words. Just remember, guys, that when you have an exponent like this, there's an imaginary 1 here. And if it wasn't for the 10 here, there would be a 1 there, okay? So when you have something like this, there's a 1 over here. 1, 1, 1. And we're adding them. So how much is 1 plus 1? 1 plus 1 is 2. Plus 1 is 3. 3 what? 3 what? Okay, we have 1 here, plus 1, plus 1. But what do we have here? These are little 3 to the power of 10s that we do not touch. We imagine them as little apples or little bananas. I don't know what your favorite fruit is. Whatever your favorite fruit is, you have 3 bananas here, or 3 apples. So you have 1 plus 1 plus 1 is 3. 3 what? 3 to the power of 10. That's what we have, because we have 1, 2, 3. So we put a 3 here, multiplied by 3 to the power of 10, because we have 3 of these 3 to the power of 10, and we're adding them. 1, 2, 3. 3 what? 3 exponents that have a base of 3 and a power of 10. Okay? And we are adding them. We are not multiplying and we are not dividing. So because we are adding, we say 1, 2, 3. This is 3. 3 what? 3 multiplied. This is a multiplication. Multiplied by the 3 to the power of 10s. Because we have 3 to the power of 10 3 times. So we multiply it to show that we have it 3 times. Does this remind you of any of these rules here? Oh my God, you're right. I know, you can't believe it, right? It reminds me of this rule right here. Ta-da! Now we can use this rule because we are multiplying. We are multiplying, which means that, remember what I told you. Remember the x with a 1 here? There's a 1 here also. Now we can do what to the exponents? What are we doing to the exponents here? We are adding. Yes. So 1 plus 10 is 3 to the power of 11. And we did it. We did it. And this is the answer. That's right. And thanks for watching. I hope you enjoyed. We're going to do the next problem in the next video. Please watch. I'll talk to you. Don't forget to subscribe. Thanks a lot, guys. Love you, and I love Saudi Arabia. Take care, guys. Thanks for watching.